So hello everyone. Welcome to the TMLS Annual Summit's virtual sessions. My name is Aarti Malhotra and I'll be moderator for this talk. I'd like to introduce our presenter, Amber Roberts. Amber is a community-oriented machine learning engineer at Arize AI, an ML observability company. Amber's role at Arize looks to help teams across all industries build ML observability into their productionalized AI environments. Previously, Amber was a product manager of AI at Splunk and the head of artificial intelligence at Insight Data Science. A Carnegie Fellow, Amber has an MS in astrophysics from University of Chile. Over to you, Amber.
Thanks so much. All right, everyone, I'll go ahead and get started. I'm going to drop some links just so folks have access to all the links I'll be going through in my presentation. So this is a 1-hour workshop, and we'll just go ahead and get started. I'm going to should be able to share my screen. Okay, yes, perfect. And where's everyone from? I'm curious, like at each one of these virtual conferences, because I know for some people it's early in the morning, for some people it's night. So just curious, like where's everyone from? We got some from Montreal, Minneapolis, Toronto, San Diego, Waterloo. I'm currently in Miami area, and my Wi-Fi just came back on like 2 minutes before this talk, so I was very happy. But you know, fingers crossed it lasts for this whole hour. We'll just do the best we can. Oh, a lot of folks from Waterloo and Toronto. Okay, awesome. I'm always curious to see like who's the furthest from the conference and like whose time is midnight right now, and they're just watching this before they go to bed. Awesome. Well, thanks everyone. Hi, I'm Amber. That was a great intro. I'll be walking you through the workshop today. Oh yeah, that's pretty late, but like you're gonna be amped after this workshop. So there's no going to sleep after this workshop. This is a super lively one. So let's put on so I put on like the few links at the top. So you can sign up for your free account for the workshop. And I'm just going to let my teammate know really quick that I did get internet back. Everyone thought I still didn't have internet. So sign up for your free Arize account. Again, you'll have access to this even after the workshop today. So you'll get to follow along with what I go through today. You'll get access to it. The links to sign up, you can, sign up, type in what's on the slide. You could go to the Arize website, or you could just click in the account link in the chat. There's also the link to the Arize community Slack. So we talk about all things ML observability, everything, everything that's like the latest topics with Arize. And if you have general questions on ML models, how to implement best practices, how to monitor them, we cover all that as well. So it's a really active community chat, over 1,000 members, and that are just looking to share their insights. I also put in a link for the free ML observability course. So we have a completely free course. It's 6 parts. It covers the main areas of ML observability. You can complete it in a few hours. And it's really nice because it's self-paced, not a big ask, but you really learn a lot just going through it. And if you like this workshop, you might like the course because I also do all the lectures in it as well. And then I put a link to the challenge. I'll go over the challenge a bit more, but it would be due tonight at midnight. And of course, there is swag involved. So that's the brief intro. Probably has given everyone enough time to join. Now we'll kind of dig into the main parts of the presentation. So again, my name is Amber. I'm a machine learning engineer at Arize. I really focus on the kind of the L&D, the community aspects of the platform. So making sure folks are implementing best practices, understanding what it means if your model is biased, understanding what it means if your models start to drift or performance starts to degrade. So I'm really focused on that educational component, and really active in our community Slack. So if any of these ideas I talk about today put yourself in a situation where you're telling yourself, hey, I need to implement this, I should see how this looks for my models, just reach out to me. I'm happy to answer any questions. So the agenda for this hour is we're going to do a quick intro to ML observability, and this timing's just rough. We're going to go over a use case, and then we're going to walk through the platform together. I know whenever we're using a new piece of tech, the learning curve on it can be a bit steep. So we're going to go through it together, do a bit of the hands-on components, get all your questions answered on kind of specific models in production, anything related to data quality, to drift, performance, to bias, explainability, anything you might have questions on, whether it's a structured or unstructured use case. And then there is a challenge. If we have some time, people can start walking through the challenge in this workshop. Otherwise, just completing it on your own time. And if you just complete that form, send it to or click submit on the Google Forms, we will reach out and want to send you some Arize swag. Our main thing is socks. We have a lot of Arize socks, so that's good. All you in Toronto, like it's getting cold up there, you need some of these really nice thick high socks. Also, I have Q&A at the end here. I'm really open to like Q&A like throughout. So I want to make sure everyone's questions are getting answered, that you're able to follow along. I know with these virtual sessions, it's really easy to like drop off or like zone out for a few minutes and then like not even remember where we were. So the key thing I want is for everyone just to understand what ML observability is, what Arize is, and if any questions come up with around your own models, let me know. I also like to ask a lot of prompting questions. I like to make this interactive. Otherwise, I just feel like I'm talking to myself for an hour. So everyone was great about putting in like where they're located, like what time zone. So we have an idea of where everyone's coming from. I'm curious, like what are people's roles? Whether you're a data scientist, a project manager, a researcher, a student, what are you all doing now? You could put like your role or your priorities. What led you to this conference? I like to understand my audience because I do tailor the talk to the different roles I see, to any requests from the audience. But this is the overall agenda. These are the main parts. And again, questions throughout. We want this to be fun. We want this to be interactive. And I'm constantly going back to the chat to be able to look at questions and answers. Okay, great. So people have already been posting their roles, what they're doing. So we have a decent amount of data scientists, machine learning engineers, software engineers, product managers, ML ops engineer. That's probably like the newest term, because I don't know if everyone remembers, but like 5 or 6 years ago, data scientist was a pretty new term. There wasn't even a major for it, and now everyone's getting hired for it. ML ops engineer, like that's the next big thing. I think a lot of us at the conference are kind of becoming ML ops engineers without fully even realizing it yet. So this is great. And it's good because everyone in here, everyone in here is, I think, in the right workshop. There's definitely a lot of useful material in here for those roles. Also going to be drinking a lot of water. As you can tell, I talk a lot and I talk fast. So constantly drinking water. All right, so we're all here because we're curious on what does it mean to take a model from research to production. When we study for interviews, right, we're using Jupyter notebooks, we're making sure everything is perfect. We're training as much as possible. We're doing feature engineering. We're doing hyperparameter tuning. We're doing everything we can to make our model as best performing as possible. The worst part is we have no idea if what we're doing is actually going to make a difference. We don't know how our model is going to do in production. We don't know the impact it's going to have on the users, especially if it's like a user-facing like recommendation system. We just don't know. And there's no way of knowing. We can only prepare the best we can. And then, we slowly start to see this performance degradation over time. Models will always degrade, but the rate of which they degrade and whether or not we're aware of it is all within, I don't know, it's all kind of within the certain boundary, right? Because when a model starts to decay, whether or not we know it's starting to decay, we know our customers' satisfaction goes down. So we really don't want our customers to be calling, complaining, saying something's wrong, and that to be how we find out that our model is underperforming. So we want to make sure we're doing everything we can to take our model from research to production correctly. And then we just want to be prepared as best we can for when that model does inevitably start to fail. Arize did this great survey. We surveyed over 1,000 companies in the industry. A majority of the folks surveyed were machine learning engineers. And we asked, how long does it typically take for your team to find and diagnose an issue in production? And 84% say that it takes at least a week to detect and fix a model issue in production. And that's pretty scary, right? Like when we think that 84% are saying at least a week, and I think it was around 14% said at least a month. A lot of times these issues go unnoticed until something big happens. Like we just talked about, when customers call and complain, that's really the situation we want to try and avoid. But also just think about the money lost when it takes so long to find an issue and when it takes so long to actually fix this issue in production. And especially like the machine learning engineers that are on this call, when these issues happen, a lot of times it's up to you to figure out where this problem lies, figure out how to fix it. And each one of these situations is completely unique. It can take forever, and it's also pulling you away from the parts that you're best at the model development, at the creating the tools needed for customers to have the best experience possible. So we really want to reduce that time with ML observability, make it a really fast monitoring, root cause analysis, and resolution. And when we talk about the companies surveyed, like we used to say AI companies, but now it's essentially just companies, because whether you're a early stage startup or you're kind of an established, like 100-year-old plus company, every team is now trying to leverage AI for predictions, for forecasting, for sales, for marketing, for even like maintenance, customer service. So we're using AI in every major realm and every industry. So making sure teams have the equipment necessary, and then making sure that they have this ML observability component so that the models they're putting live are being responsible and they're making quality decisions that we can then monitor. And if there's any questions on these slides, please let me know. I'm continually, like I said, going back, checking the chat, and checking the slides as well. So a lot of these issues, when we talk about issues in production, they come from the time that's actually spent on that ML pipeline. Let me know if you agree, but what we see is a majority of the time is spent in the data preparation phase. So that's the data curation, the data cleaning, because as we know, like you can have great models, you can have great machine learning engineers, but if your data is terrible, the models aren't going to perform well. So that data prep is definitely necessary and is a huge portion of that time in the ML pipeline, where the next step is the model training, then the model development, then production. And as you can see, production is this tiny window because we found from that survey that teams spend on average less than 1% of time in production. And it's not because it's a boring area to be in. It's not because it's not fun. It's because there's a lot of challenges that haven't been figured out with that time in production. Some of the most common problems we see that plague teams in production are model and data drift, performance degradation, and data quality issues. And then there's also more issues coming up we see all the time around fairness and bias and model interpretability. So it's that these issues are new in comparisons to like what we have been trained for. So whether it's something you learned in a degree, something you've learned from an online course, there's not a lot of material that really helps you understand these problems that are in production. And what we see a lot of teams do is that for that beginning part of the machine learning pipeline, they're using existing tools that have been well vetted, they're established, they integrate great. They integrate great. They do. And they're very sophisticated tools for a sophisticated ML pipeline. And so you put together the beginning part of that machine learning pipeline, and then you have this last mile, right? Where it's that post-deployment phase where, you don't want to just say, okay, I deployed it, I'll train it again in 6 months, or I'll train it again in a year, or I'm just going to train it every single day. You want to be able to have a bit more sophisticated of an approach to know when it's actually necessary to retrain your model. And what some teams will do is they'll use a set of existing tools, try to repurpose them, try to kind of duct tape them together, and be able to use them for that last mile. The problem is trying to use a lot of different tools for a lot of different purposes. First, the integrations could be really messy, but also you might not be getting everything you want. If you're having a model go down for a certain type of drift and what you have in place doesn't capture that, then you could be losing customers, you could be losing revenue, and you think you're doing everything you can because you have some tools in production, which some is always better than none. Anything is infinitely better than zero, right? But what we really want is something like ML observability. And I've actually added a definition because some people may have come to this talk on ML observability thinking they're going to get more information on network observability. And just to kind of clarify, ML observability is the software that helps teams automatically monitor AI, understand how to fix it when it's broken, and improve data and models. So just to kind of add a definition to it. And I also like talking about the key differences. So you have ML observability and then you have ML monitoring. So ML monitoring is 100% necessary. You should set monitors on your models. Normally these monitors are around drift, so data drift, concept drift, prediction drift, around data quality issues, also around performance issues. And these are necessary, but that's just the tip of the iceberg. So monitoring, is that first step to making sure your models are doing well in production. The observability part is that step deeper. That's the actual root cause analysis. So being able to find where your model is underperforming, how to troubleshoot it, and then how to fix it when it's broken. So you're figuring out how to resolve these issues as soon as you're alerted to like a monitor triggering. Okay, we're going to get a bit into the kind of hands-on workshop component now, but any questions on what I just went through, questions on ML observability, how it can relate to your use case, anything that's kind of on your mind or top of mind as I'm going through this. Otherwise, we'll just get right into the workshop component. Okay, looks good. And then again, anything that comes to mind, just put it in the chat. There'll probably be a lot more chat like once we actually go through the platform. So again, sign up for your Arize account. The link, if you just want to click on it, the link is in the chat. So you can go create your account. It takes about a minute and you'll have access to this account after the workshop. You'll even be able to put in your own data, set up your own monitors, and test the platform for yourself. We're going to go through a fraud use case. If you have a particular use case you rather use, these workshops for me are pretty flexible. If several people want a particular use case or something they're personally struggling with, like at work, I love to use this time and try to troubleshoot that directly. But for simplicity's sake, I like starting with a fraud use case because we could all put ourselves in that scenario where we're a machine learning engineer at a bank. We build a model to determine whether or not a customer's credit card transaction is fraudulent. And then we have to keep in mind what we need to monitor, what KPIs might suffer. So there's a lot of data scientists and machine learning engineers in the chat. It doesn't matter if you've actually built a fraud model before, but what are maybe some things to keep in mind? If you're building something to detect fraudulent activities, what do you need to be kind of conservative on? What are things you have to keep in mind when building this model? And I'll go into the chat here. If anyone has certain ideas, even around like customer satisfaction for kind of going through and building these models, like what do you think in mind, or what do you think? What do you keep in mind? What do you think of like when you're building these machine learning models? And what's a priority for you whenever you're going through the process? Because it's really easy to kind of get lost in the actual model building, model development component. When we think of the MLOps lifecycle, what are we thinking? What are we keeping in mind? I think the chat's broken because I know everyone's trying to type at once and put in their answers, but they're just not coming through right now. Oh, great. They're starting to come through. The rate of false positives. Yes, we want to think of, how much true fraud is getting through our model, and how much fraud did we not detect, right? So keeping that in mind. Some people are probably still thinking, but when we look at there's certain KPIs, we also want to think about, if we're really conservative or if we're not, if our model is saying that, a lot of things are fraud versus not fraud, we have to think of our client churn. We have to think of loss in profits. We have to think of chargebacks. We have to think of like an overwhelmed contact center of people constantly calling and saying, hey, my credit card's being used, I didn't get alerted to it, or that's me, I said I was going out of town, and you still flagged this transaction as fraud. So we want to maximize both. We want to make sure customers are happy and that we're not losing money in chargebacks. So for the metrics we're looking at, someone already said, looking at, I think it was, the rate of false positives. There's a lot of different metrics we can look at. I'm going to look at similar to what someone put in the chat, like the false negative rate. So also known as the miss rate. So the probability that a true positive will be missed by the test. And great for whoever got that in the audience. I think it was Sona. So the false negative rate, miss rate. So the higher it is, the closer it is to 1, the more fraud that is getting through. We actually already kind of covered this, like people have put models into production, but we didn't really talk about what makes monitoring a model difficult. I know there's at least 1 or 2 people in the audience who have put a model into production like on a Friday night, and you don't have to say who you are. But what makes monitoring models challenging in production? And this could be any kind of model. It doesn't have to be a type of fraud model. It doesn't have to be a classification model. It can be regression. It can be unstructured. And there's not a right answer to this because there's a lot of things that make it difficult to monitor a model in production. But does anyone have personal experiences with these types of challenges in production? I'll give everyone like a second to kind of input some answers. So looking for anyone that has had either personal experience, or we can say like a friend that has had these types of experiences, and it really makes it difficult for monitoring a model in production. I've worked with a lot of like researchers who have been trying to get roles as data scientists and as machine learning engineers, and they're also asked the question, this model you worked on, is it live? Is this model, is it having inferences? Like, are you monitoring this model in production? Because a lot of times the answer is no, but how do you monitor it in production? A lot of times these interview questions are now focused on making sure machine learning engineers are thinking about who these models impact and like what makes it so challenging to actually monitor these models in production. We'll just go into like a few examples. Sometimes the types of models, knowing what to monitor can be really important, really difficult. In the scale, People that, well, especially like teams that have high volume, have a lot of inferences, teams that are in like the ad tech space or are very large companies that are handling a lot of data, the scalability of that monitoring can be really difficult as well. So let's go through our walkthrough. All right, so right now, like sign into your account if you haven't already. You can go through that in the Arize links. Let me know if you have any trouble with that. It should take about a minute to set up. This is what we'll be going through the rest of the time. There's, and also like in that link, you'll be able to sign up for the Arize community Slack. If you have any questions on your own models, or you're interested in getting your own models into Arize, you can also message me on the Arize community Slack, and we can work those out. You might notice when you first log into the Arize platform, like you'll be taken to this page. And so this is going to be the quick start guides. So if you have something like a computer vision model, an NLP model, a click-through rate model, some different models here, or you're looking for a particular workflow like bias tracing, embedding troubleshooting, you can go through these at your own time and it will walk you through the platform. So you can, it's kind of like having a hands-on workshop, but this will guide you through. To get to the homepage, just click on the Arize logo and it will take you to this homepage. And you'll have the exact same account that I have here. These are demo models, so these have already been put in the account for you, so you can use them. You can play around with them as you like. Give everyone a minute just to create that. I'm going to go back and check the chat to see if there's any questions on this. All right. Let's see here. Oh, great. So we don't see your account. You don't see the, I see it on my shared screen. Nikki, do you see my like Arize account? This one, I just created it too. So it's like it shouldn't have anything on it, just like the amber TMLS space. Do other people see? Okay, you're seeing the dashboard. Okay. Okay, so interesting. So Nikki, you're still seeing the slides? Okay. Tashin, you're seeing the dashboard. Okay. So does everyone else see the like the Arize like dashboard, the one with models live, prediction volume, model versions? Okay. So everyone else is seeing the account. Nikki, why don't you message one of the administrators and they can probably help you up. Your screen might just be like locked for a second. And I want to get back to Sona's comment about drift. One of the challenge I faced was how the model selling went crazy when demand pattern changed. That is a great example of like what we're going to go through because a lot of models have experienced drift. Anyone else like have a model they put in production experiencing drift? I will say this happened a lot during the pandemic. Historic data was no longer relevant, especially for forecasting. And so a lot of these models started to change. The landscape started to change, and then how people were just kind of handling decisions, right? Like the pandemic, it was a lot of data drift, a lot of prediction drift. So drift comes in a lot of different shapes and sizes. And if anyone's wondering, like, why would you use drift if you have performance? All right, Nikki's back. Perfect. We're all on the same page. But if you're wondering why teams sometimes use drift instead of performance, it's mostly because they don't have those ground truths. So they don't have those actuals. So if you're having like a churn model and you're slowly getting back churn, but it's like a 30-day churn model, you're not going to be able to make any performance calculations until after those 30 days. But during those 30 days, you can look at drift. So that's what we're going to do. And we have 30 minutes. We're going to try to get through a lot. You've heard me mention some kind of like hot topics. kind of buzzwords around the space. So we are definitely going to cover drift. We're going to cover performance, but if you're interested in explainability, fairness and bias, specifically bias tracing, if you're interested in like unstructured use cases, I'm trying to think some of the other ones we go through in dashboarding, how to record all your dashboards for these models, you can put that in the chat, and I'll definitely make sure that we get through those topics. Okay, perfect. All right, so we're going to go in and first set up our monitors. So when you log in, you'll see that your fraud monitors are already put into place. For this, you're going to set your baseline and set your monitors. I'll go in and set a brand new one up so you can see what this looks like. But if I go into something like credit card churn, for example, I want to set my model baseline. So you're always going to want to set a model baseline for your monitors. And this could be any baseline. A lot of teams will use their baseline to be their training. Essentially their training data. So whether that's a window in production or a training data set, that tends to be what it is. But I can configure this baseline to be whatever I like. As I mentioned, this could be a training version. So if you have your data kind of in its own training data set, you can use that. You could use a validation set or a window on production. So currently for this model, I'd have to look at the latest data, but you can select a fixed time range, a moving time range, really whatever you like there. And when you wrap it up, you'd be able to propagate those monitors on drift, data quality, and performance. So for example, after I set up the baseline, maybe I want my performance monitor set to a given metric. You can also put in custom metrics. So if there's a particular one that your team uses, you can use that. You can set your drift monitors, your data quality monitors, kind of just set these up automatically. You can send alerts. So you can send them to yourself, or if there's anyone you just want to blast with emails, you can set some really open monitors and just put in their contact information. You can also configure Opsgenie, PagerDuty, Slack, and you just finish that up. And then your monitors are going to set on each of these. So note, this is the kind of just the step one. This is the automated approach. I'd say teams really use two different workflows. There are the teams that just want smart monitors automated and propagated. And then there are teams that really want to work on the exploratory phase. They really want to dive in, set individual monitors. They want to customize their monitors. They want to set it on a set of, say you have a feature that is like states or something. You can set West Coast, you could set East Coast, you could set all these monitors, and you can continue to stack those monitors. You can set as many monitors as you'd like. Arize, I'll just put this out. Arize is a volume-based pricing model. So you can have as many monitors as you like. You also, in the free account, have access to probably 90% of the capabilities that a lot of our enterprise customers have. So, we don't restrict the different capabilities that you have, so you can use them. All right, so I'm going to go back into my fraud use case here. And when you first log into the Arize platform, you'll see the name of your model. So, and then however you got your model into the platform, teams will typically use either a Python SDK or a file importer, or they'll use an API. And you could set your monitors on them as I just showed you, or it could be programmatic. I think because we have some different integrations, and we have GraphQL. I'm not sure if that's available for the free version, but we have ways. So if you really want to programmatically adjust your monitors, you can. All right, take another sip and check the chat if any questions came up from that. All right, looks like everyone's able to follow along. All right, so we look at our performance over time. Again, I said we're going to look at our false negative rate. So the higher the false negative rate, the higher the miss rate, essentially, the more fraud that's getting through. We have an overview of our model schema. So our categorical features, our numeric features, embeddings, tags are metadata, our predictions, and then our actuals. Our actuals are ground truths. So you may not have embeddings, you may not have metadata, you may not have actuals or ground truths, but even by having your predictions and your features, you're able to monitor for drift. So let's get into, we'll actually go to drift first. We can go into it directly from a monitor that is a troubleshooting monitor that has triggered. And the kind of workflow for that is, you're setting up your monitors, you get an alert, you go into the specific monitor that has triggered, and then you can troubleshoot drift. This is also like just an inside look into these monitors. And again, they are fully configurable. You can delete all managed monitors. The managed monitors are the ones that are automatically created. You saw all those monitors get created. They're really useful for teams that have incredibly wide models. So if you have, let's say you have a model that has over 1,000 features, yeah, you can set them by hand each time. But we just set performance, drift, and data quality for all 1,000 of those features. And you saw how fast that was. And you can also set them on metadata. So what teams will normally do is they'll set the configured monitors, and then they'll go back, and if there's something particular that they care about, either a set of inputs, a certain like prediction range, whether it's a particular tag they have, they can set that and get alerts to that in particular. And then they can set their own email for those particular alerts. Maybe they're looking at user activities. Maybe they want to track power users. You can do all that as well. Okay, so when we go through and look, so I could choose to edit this monitor or delete it. Here you see the kind of auto thresholding. You could change this and make it kind of a set score, but smart monitoring is what a lot of teams want to use, and then they set kind of the window that they want to use as that baseline. Okay. If there's any questions on this, let me know. We can also go into how data quality monitors work, how performance monitors work. Each one of my workshops is pretty tailored to what the folks in the audience are asking to see. So just note that I can go through those as well. But that's pretty much an intro to monitoring. If we want to troubleshoot, that's where a lot of folks choose our platform, because it's not just about getting a red or green light. It's getting a red light and then showing where that red light exists in the data so that you can then fix it, resolve the issue, and continue to monitor in production. All right. All right, we do have a question in the chat. Awesome. Thanks, Sona. And if I'm completely mispronouncing your name, message me after. I'd love to know if I'm saying it correctly. So, all right, I'm good. Thanks, Sona. Okay, metrics for drift, data quality, and performance. Is it possible to see the computations behind them? That's a great question. So the metrics that we currently have for, and I'll just do edit monitor now. So for our drift metrics, we have our PSI, a duplicate custom monitor. Here we go. Right, because if you want to delete it, you can, but we also want people to be able to just duplicate it off the bat. So we have PSI, KLA divergence, JS, and KS. And I've actually been putting out a lot of pieces on these in particular. So if there's any you want to know, like particularly about, we mostly do a PSI, and then we have researchers that have modified it to be better for binning. So we use state-of-the-art monitors for drift. They have to be configured in a way that is highly scalable, and it's just kind of the cutting edge. We love talking about how we're actually calculating those and computing those and how we're doing it in research, and how we even test different industries, different use cases in order to figure out which drift metrics actually work the best, especially as a default. So if you're interested in learning more about that, I'm happy to chat about it. And then for our performance metrics, a decent amount of the time, they're the same as scikit-learn. There's a lot in our documentation. Docs are just Arize, docs.arize.com. We have that. And then we have metrics like we have things like, actually want to kind of show you this. We're putting out a lot of pieces around things like what is AUC, what is PRAUC, along with graphics, just to help folks like with the understanding of these. I just put one out either this week or last week. That was what is precision, what is recall, and really thinking about it from a production standpoint. Maybe that's a little bit more in depth than you wanted for your answer, but it depends. We really put a lot of research behind the metrics we use, but we also have user-defined metrics coming out so that folks can use, if they want to use their own version of like PSI, if they want to use their own version of a recall, something like very specialized, or their own like version of a ranking metric, they can put those in as well. All right. Awesome. If there's any more questions like that, just let me know. I love talking metrics. So, all right, perfect. Oh, and I'll keep editing this just to show. You can show like the distribution comparison. So what we're seeing is the so when you see the kind of green blue color, that's your current distribution, and then the purple color is going to be our baseline. So a lot of times our baseline is training. Here, we're not seeing too much of a difference in our PSI, but you're just going to be able to see that as you go through it. I'm going to cancel these changes. And then I'm going to troubleshoot drift. So when you click on troubleshoot drift, you're actually taken into the drift section of the Arize platform, and you can go in, click on individual data points. You can change out the look back period as well. I know it only 1 hour. There's really a lot to grasp, but just note that it's very configurable. It's easy for you to compare different versions as well. You can link up production, pretty much whatever data you put into the platform, you can easily look at it, compare it, you can filter it, and kind of see how this data is drifting. If we want to get just an overall view of drift, we can go into our drift tab, and we can see our PSI, or population stability index. We like using a population stability index because it's similar to KL divergence in that it looks at the difference between two given distributions, but PSI has a symmetric property. You can derive it the same way that you can derive KL divergence, but it's pretty robust. So symmetric in the sense, like if you have distribution A and distribution B, the way the calculation is made for PSI is it doesn't matter which one goes into the equation first, you're going to get the same result. It's also generally known that if you have a PSI above, I would say, if you have a PSI like above 0.2, it tends to indicate significant drift between the two given distributions, and you have like a moderate amount, you have a severe amount. So it's great when putting it on to a lot of different features. Here we can see there's some spikes where our PSI gets pretty high from the incoming. So if I go into this particular date, for example, I can actually see how the distributions start to change. I have different options for binning as well. Whether it's a score or a class, and I can filter down as well. So just note a lot of those differences. And we're starting with drift because a few folks in the chat mentioned drift being a problem. Okay, so, and the way we break down drift is we like to look at feature importances. So your feature importance comes from your strat values, but we use feature importance as a tool, normally as a way to rank or triage our like the importance of our features. But we like to use this in conjunction with something like a drift score or a performance score. So we have a prediction drift impact. So if we multiply feature importance by drift, so we could say this is the most important feature that's drifting the most, then we can look into these individual features and actually look at that drift. So here we're seeing California, we're seeing New York, we're seeing it with our current or production distribution versus our baseline or our training distribution. And then we're seeing how it's essentially how it's going. So when there's little PSI, you see that the distributions are pretty similar. So let's go when there's a large spike in PSI, because here we're actually seeing that there's kind of a big difference in our expectations versus our reality. So the volume is a lot higher in our current, or sorry, is a lot higher in our baseline distribution than our current distribution. So we're kind of over predicting that, you know, there'll be more volume from California because it's what's in our training data than there actually is. Same, I guess, like, well, the opposite for New York, under predicting. Texas, we're having a lot of current data that we didn't really see in our training, and more in Florida as well. So it's kind of taking it from California and trading it off. So you can look at different features and see how they kind of come together and how they correlate to really diagnose there. And again, I can like filter. So a given feature, a given slice of metadata, a lot of teams will stack on metadata to this as well. Prediction scores, actuals, and any given features or a selection of that features. Like maybe I don't care about features that have a very low volume. I don't care if that really low volume is drifting. So I can filter on the ones with the highest volume, the biggest states or the states with the biggest cities. I can do that. All right, any questions on drift before we get into performance? And I'm going to go back to my questions. I really need a monitor. I don't know, I'm sure you all have like monitors. Some of you probably have like 5, but I like just having the one screen. All right. Oh, we got some good questions here. So is there a way to monitor if your resources are close to needing tuning? So maybe give. Oh, you gave a little more detail. Okay, so meaning filling up, like need to add resources. Is that, do you mean like cluster resources? Let me know. But there is a way to look at your ingestion, and so there's 2 different options for Arize as well. So there's the on-prem option and there's the SaaS option. So if you're using the SaaS option, we do send like reminders, like the same way you get kind of alerted to your resources on GCP. We send out like, oh, this was like the volume you wanted dedicated to this month. Like this is your kind of reach there. So yes, like the monitoring on your resources, like your data ingestion, those come normally from the platform or from whatever you're setting the cluster on, if that's what you mean. So like, because like we work with, a lot of folks have us and Datadog and they're running them, and then Datadog showing them kind of like the network, some the behind the data, data ingestion, and we're also sending alerts. For this platform, we're sending alerts around the data that you're sending into Arize. So all alerting on data quality, on performance, on drift. that's being sent into the Arize platform. Let me know if that answers your question. Okay, we got a few other questions from Lavi. Can Arize know about causality between signals and point to root cause alerts? Yes, we can. And multivariate signals, even better. And yes, we do have them particularly for vectors because we do embeddings as well. We only have another 10 minutes, but Lavi, why don't you reach out to me? I also put my LinkedIn. It's the first at the top. Wonder if I can pin this. Looks like I could like it. Okay, I liked my own comment. It's the first one at the top. Connect with me on LinkedIn because if you do have embeddings or unstructured use cases, we do a whole UMAP projection. We do clustering, and we have some really, really cool stuff going on there. So I'm sorry I lose my voice. When it gets to like the 10 minutes of I start to lose my voice. So let's dive in quickly to the root cause analysis aspect and get going. Okay, so I'm going to go into performance tracing. Again, this is another way that teams look at that root cause analysis. So if you get an alert on data quality, on drift, on performance, you'll be taken to a way to really dive in and see what that alert is telling you, where it's telling you in the data, and help you figure out what you need to do to resolve it. Okay. So for a performance breakdown, so we're looking at data set A, and we're looking at our false negative rate, and then we're looking at our performance breakdown. So this has our features, it has our tags or metadata, and then it has our individual features and the breakdown of those. So we're also using feature importances, and then we have these worst performing slices because a lot of the time it's not about what feature has the highest feature importance or SHAP value. It's about the volume. So what features are bringing down your performance the most based on the performance score and volume. You can click into these individual features. Maybe just make this a little larger, folks. So we can see that we're looking at particular merchants, merchant IDs, and again, for false negative rate, so the lighter, whiter, yellower the score is, the closer it is to best performing. And then the darker or redder the score is, the worst performing it is. So here, if we're getting kind of a yellow color, we're close to 0 for a false negative rate, which is the best performance we can get. And then if we're at 1, we're at the worst performance. So we see this merchant ID scam ads is performing really poorly compared to overall. We're seeing California is performing pretty poorly. We saw that pretty much in our drift as well. So what I'm going to do is I'm going to add a comparison and look at different versions. So this is really important if you're interested in version control as well, because you can look at production, you can look at training to training, validation to training, production to training. So we're actually going to either, maybe we look at our training set, or we just look at where the model's actually performing really well. So I can select kind of when my model's performing well. I can select when it's performing poorly. Maybe this corresponds. Sorry, I'm really losing my voice now. So this could correspond to when the model is performing very well compared to what it looks like for when you're training your model. So as you saw, like we just zoomed in on an area that's really underperforming. It has a really high false negative rate. That's like an 84%. That means a lot of fraud is getting through. And when we see our training or like kind of our more stable parts of performance, we're seeing a score that's half that. So the way we break this down, again, now we can see mirrored histograms. So if I click on merchant ID again, I'm still seeing scam ads performing really poorly. And then I'm seeing right here, so if this is my training data, then what I'm seeing is that my training data, it doesn't exist here, which most likely means that I didn't train my model on this user. So let me just go real quickly back to the... Okay, so Lavi, that was what you were asking about. Like, can we trace it? Yes. So we looked at our essentially our training. We looked at where there was a spike in essentially underperformance, where performance was starting to degrade. We compared the two, and then we can see which features like merchant, for example, are bringing down the performance. What I can actually do here now is I can add this cohort as a filter. I could exclude it. I can view the explainability components. I'm just going to exclude this and see if it brings up my performance. Okay, so it brought my performance up about 10% by excluding it. Now, we're not removing any data. We're just saying, hey, if my model wasn't basing decisions on that data, would it start to have better performance? And the truth is that it would. So I'm adding that filter here. And so you can see you could have the feature, you could have the merchant ID, you can have not equal, you could have both data sets, you could exclude it between data sets. You can continue to add filters, you can reset those filters. And this, as you can see, this goes really fast. You're able to look at complete performance breakdown across all your features, all your metadata. You're able to exclude that on segments of data. And then what a lot of teams do is they'll just export some data, use it to retrain their model, and then see how their model is now doing on predictions of the merchant scam ads. We also saw how it was doing with state, for example. Performance is kind of poor in California. You can add features to this as well, and feature filters. So you can continue to add those, stack those as you would like, and see how that performance is doing. All right, any questions on what you're seeing so far? I'm going to go back to the chat. Sorry, my voice is starting to kind of go downhill. Yeah, it's really like that last 10 minutes that I start to lose it. But yeah, if there's any questions relating, so we didn't really get to bias tracing. That's pretty important for a lot of folks. And that is available in the Arize, it is available in the Arize course. You could go into our fairness tab. It's very similar to how we do performance, but we're using bias like parity scores. So you can use that. I'm going to go back to questions. All right, we've got a question from Nikki here. Okay, so for California, we can see that training data does actually include the state. How do we find the root cause in that example? Great question. Let's see if we can get it before I time out. Right, so we can tell like when, we don't have training data, for example, and when we need to retrain our model. And so here now we're seeing like, okay, we see that we're not doing well in California, but we're doing fine here. So what I would actually do is go back to drift, because we saw a drift monitor trigger as well. And normally what you would see is probably drift would trigger first, followed by performance, until you get those ground truths back. We're able to look at that here. And so this is where we're looking at California, seeing how it's doing here. And when it really starts to drift, so we're seeing a lot of drift in our states. And so just because we didn't, or just because we did include California in our training data, it looks like just for how we're distributing that set, that training distribution is very different from what we're seeing in production for California. And that's mostly because of the volume. It's a very high volume. And we're not doing great on the other states, again, likely due to volume. So I'd look at those training distributions like for that state. And if this was like a real model in production, this is just a toy one, you're likely to have meta associated with that. And you can use that in your performance and in your drift to start filtering on that metadata. For example, like if this is fraud in California, like was there a recent law bill? Like is there a particular event that's causing a lot of fraud? Is the fraud in a particular area or zip code of California? Is it within a particular subset of individuals in California? So you can add those all as well. So it's like doing a million SQL queries, but just in like one bird's eye view, and you can continue to filter that down for as much data as you have, and find those correlations, and maybe even just seeing like, hey, I was training on historic data from a weekend, and this was a weekday, and just kind of making those corrections. Well, it's 3 o'clock. Thank you so much, everyone, for asking such great questions, for staying with me as my voice is leaving me. I hope everyone has a great weekend. And if you have any questions, please connect with me on LinkedIn and on Slack. I'd love to continue this conversation. Thanks, everyone.